Fellow gardeners, what if I told you that the most incredible transformation on Earth is happening right beneath your feet, completely unseen? Every autumn, as leaves cascade from trees and settle into seemingly lifeless piles around our gardens, we're witnessing the beginning of nature's most essential recycling program. This isn't just debris cluttering your landscape, it's the foundation of all terrestrial life, and understanding this process will revolutionize how you view and manage your garden ecosystem. Nature's hidden recycling plant. Walk through any forest or well-established garden, and you'll notice something remarkable. Despite centuries of leaves falling, the ground isn't buried under mountains of decaying foliage. Instead, you'll find a rich, dark layer of what appears to be soil. This seemingly magical disappearance isn't magic at all. It's one of nature's most sophisticated biological processes in action, and it's been perfecting this system for millions of years. When fresh leaves first hit the ground, they arrive as complex structures filled with cellulose, lignin, tannins, and various nutrients that the tree has invested significant energy to create. These aren't waste products being discarded, they're valuable resources being strategically deposited to ensure the continued health of the entire ecosystem. The tree essentially creates its own fertilizer delivery system, packaging nutrients in a slow-release format that will feed the soil community for months or even years to come. This leaf litter layer, which ecologists call the duff layer, serves multiple critical functions before it even begins decomposing. It acts as a protective blanket for the soil, moderating temperature fluctuations that could stress soil organisms and plant roots. During heavy rains, it prevents erosion and reduces the impact of water droplets that could otherwise compact the soil surface. In dry periods, it conserves moisture by reducing evaporation, creating a more stable environment for the countless organisms that call the soil home. The real transformation begins when an invisible army of decomposers discovers this feast of fallen leaves. Bacteria arrive first, colonizing the leaf surfaces and beginning the initial breakdown of simple compounds. These microscopic pioneers are followed by fungi, whose thread-like hyphae can penetrate deep into leaf tissues, accessing complex compounds that bacteria cannot digest. This fungal network becomes the primary driver of decomposition, breaking down tough lignin and cellulose structures that give leaves their form and strength. As the leaves soften under this microscopic assault, larger organisms join the feast. Springtails, tiny primitive insects no bigger than a pinhead, begin shredding the weakened leaf tissues. Mites, millipedes, and other soil arthropods contribute their own digestive capabilities to the process, each species specializing in different aspects of decomposition. Earthworms, perhaps the most famous of soil creatures, consume partially decomposed organic matter and excrete it as nutrient-rich castings that further enrich the developing soil. What makes this process truly remarkable is how each organism's waste becomes another organism's food source. The bacteria that initially colonize fresh leaves produce byproducts that fungi can utilize. The fungi in turn break down complex compounds into simpler forms that bacteria can process more efficiently. This intricate web of interdependence ensures that virtually nothing is wasted. Every molecule of the original leaf eventually finds its way into the soil ecosystem, or back into the atmosphere as carbon dioxide, completing the carbon cycle. Temperature and moisture play crucial roles in determining the speed of this transformation. In warm, humid conditions, decomposition can be remarkably rapid, with soft leaves like maple or basswood breaking down significantly within a single growing season. Conversely, leaves high in tannins or lignin, such as oak or pine needles, may persist for several years, slowly releasing their nutrients in a more controlled fashion. This variation in decomposition rates creates a diverse soil environment where different nutrients become available at different times, supporting a wider range of plant species and growth patterns. The dance of decomposition revealed. If you could watch this process unfold in fast forward, you'd witness what appears to be a choreographed dance of disappearance. The crisp edges of freshly fallen leaves gradually become soft and pliable as cell walls weaken and break down. Colors fade from vibrant reds, oranges, and yellows to browns and blacks as chlorophyll remnants and other pigments decompose. The distinctive shapes that once allowed us to identify maple from oak become increasingly obscured as the leaf structure collapses. During this transformation, the leaf litter undergoes several distinct phases. The initial colonization phase sees rapid population growth of bacteria and fungi as they consume the most readily available nutrients. This is followed by a fragmentation phase, where the physical structure of the leaves breaks down through the combined action of microorganisms and soil invertebrates. The chemical composition changes dramatically during this period, with complex organic compounds being broken down into simpler forms. So, the final phase, humification, is perhaps the most important for gardeners to understand. During this stage, the remaining organic matter is transformed into humus, which is a stable, complex mixture of organic compounds that can persist in the soil for decades or even centuries. Humus is actually the dark, rich material that gives healthy soil its characteristic color and earthy smell. And it's also incredibly valuable for plant growth, since it can hold nutrients and water far more effectively than mineral soil alone. Throughout this entire process, the volume of organic matter decreases dramatically. A thick layer of fresh leaves might reduce to just a thin coating of dark humus, but this apparent loss represents a massive concentration of nutrients and beneficial compounds. So, what began as bulky, relatively nutrient-poor leaf tissue becomes a concentrated source of plant-available nutrients and soil-improving compounds. From litter to life, the humus revolution, the end product of leaf litter decomposition, is nothing short of miraculous. Humus, the dark, crumbly substance that remains after complete decomposition, is perhaps the most valuable component of any garden soil. This stable organic matter improves soil structure by helping clay particles aggregate into larger, more porous clusters, while simultaneously helping sandy soils retain moisture and nutrients. The result is soil with improved drainage, better water retention, enhanced nutrient availability, and superior root penetration characteristics. So humus kind of acts like a biological bank account for your garden, storing nutrients in forms that plants can access when they need them, while also preventing these nutrients from just washing away during heavy rains. It provides what's called cation exchange capacity, which basically means the soil can hold on to positively charged nutrients like calcium, magnesium, and potassium, making them available to plant roots over long periods of time. Plus, humus contains organic acids that help make nutrients, ones that might have been locked away, accessible to plants by chelating them, or even by slightly acidifying the area right around the roots. The biological benefits of humus actually go way beyond just storing nutrients. This stable organic matter serves as both food and habitat for tons of beneficial soil organisms. Mycorrhizal fungi, which form these cool symbiotic relationships with plant roots, rely on the carbon compounds in humus to really thrive. Beneficial bacteria that can fix nitrogen from the air or help plants fight off diseases also need the energy sources humus provides. And even bigger soil critters like earthworms totally depend on humus-rich soil to keep their populations healthy. Now, maybe most importantly for us gardeners, humus-rich soil is just incredibly resilient. It bounces back from compaction way more easily, resists erosion better, and keeps moisture levels pretty stable through both wet and dry spells. Plants growing in humus-rich soil tend to show greater resistance to pests and diseases, mostly because the diverse soil biology that humus supports creates a naturally balanced ecosystem that helps keep harmful organisms in check. So, here's the secret I want to share. Understanding the leaf litter decomposition process should fundamentally change how you manage organic matter in your garden. Instead of viewing fallen leaves as waste to be removed, start seeing them as valuable resources to be strategically deployed. Rather than bagging leaves for municipal pickup, consider how you can harness this natural process to improve your garden's soil health and reduce your dependence on external inputs. The most direct application is simply allowing leaf litter to remain where it falls, particularly under trees and shrubs. This really mimics natural forest ecosystems and provides all the benefits we've discussed without any additional effort on your part. For areas where you prefer a tidier appearance, consider gathering leaves from paths and open areas and relocating them to planted beds where they can decompose naturally while suppressing weeds and conserving moisture. Creating dedicated composting areas where you can concentrate leaf litter with other organic materials accelerates the decomposition process while giving you more control over the final product. Mixing leaves with nitrogen-rich materials like grass clippings or kitchen scraps balances the carbon-to-nitrogen ratio, speeding decomposition and producing higher-quality compost. Regular turning introduces oxygen, which shifts the decomposition from slow anaerobic processes to faster aerobic ones, reducing odors and producing more beneficial end products. For gardeners dealing with large quantities of leaves, consider creating leaf mold, essentially composted leaves without other organic matter added. This process takes longer than traditional composting, but produces an exceptional soil amendment that's particularly valuable for improving soil structure and moisture retention. Simply pile leaves in an out-of-the-way area, wet them down, and allow nature to work its magic over the course of 1 to 2 years. The principles of leaf litter decomposition also inform other garden practices. Understanding that different organic materials decompose at different rates allows you to create layered mulching systems that provide both immediate benefits and long-term soil improvement. Fast decomposing materials like grass clippings provide quick nutrient release, while slower materials like wood chips or oak leaves provide long-lasting soil protection and gradual nutrient release. Remember that this process is happening constantly in your garden, whether you actively manage it or not. Every fallen leaf, every piece of plant debris, every root that dies and decomposes is contributing to your soil's health and your garden's long-term sustainability. By working with these natural processes rather than against them, you're not just improving your garden, you're participating in the ancient cycles that have sustained life on Earth for millions of years. The humble pile of leaves in your yard represents one of nature's most sophisticated biotechnologies, refined through countless millennia of evolution. By understanding and harnessing this process, you're tapping into a source of soil improvement that's both free and incredibly effective. Your plants will respond with improved health and vigor, your soil biology will flourish, and you'll reduce your environmental impact while creating a more sustainable garden ecosystem. Ready to transform your understanding of soil health and discover more secrets hidden in your garden? Subscribe to the Living Soil Lab for more deep dives into the fascinating world beneath our feet, and share this guide with fellow gardeners who are ready to unlock nature's most powerful soil-building secrets. Together, we can grow healthier gardens while working in harmony with the incredible biological processes that sustain all life on Earth.